picture every time I did that. All right, Jeff, it's all right. Let it alone. Okay. Let's see. So, what the hell are like terms? What does that mean? Somebody tell me what like terms means. An example is easier, I know. So give me an example of like terms.
If there's an equation, say there's two numbers that end in x,
Okay.
you can just add them,
I like
subtract them, or multiply.
So if I said there are 2 chairs there, and there's 2 more chairs there, I got 4 chairs, right? But if I said there are 3 pineapples there, and 2 chairs over there, I don't have 5 of anything. I don't have 5 pineapple chairs. That's weird. It seems like it would hurt. Pineapples, you ever held them? That's the next level of chair we're going to get here. So yeah, if I had 4x plus 2x, well, how many x's do we got? 6. I love it. Don't give me, what are you going to tell the person that says this? That's wrong. Don't write that. That is wrong. That's the right answer then. That's the right answer. Write that. What would you tell the person who wrote that? I'll tell you what I would tell them.
Stop it.
Stop it! I would say this. I don't see any x squares here, anywhere. How did you get 6 of them? That's my standard thing I said. Because all a coefficient, what's a coefficient based on? Oh shit, what does 4x really mean? Don't say 4 times x. That doesn't tell me what it really means. Yes?
4 times a number?
No? What is the coefficient really? 4x is doing what? Adding. So this is x plus x plus x plus x plus another 2x. So of course I get 6 x's in the end. So coefficients just keep track of how many of these you've got. I like it. I like it. Again, if this is old news for you, great. Enjoy it. If I'm going too fast, slow me down. If I'm going too slow, deal with it. Okay, so that's this. That's like term. So what about this? 4a minus 3b plus 6a minus 2. In that expression, where are my like terms? 10a. Yeah, I've got 4 a's. Do I have any more a's? Yes. How about b's? I got 3 b's. Do I have any negative 3 b's? Do I have any more b's? No. Oh shit. And then what about numbers? Do I have any more numbers? No. They're all one. So 4a and 6a, of course, is 10a. And then this guy's by himself, and this guy, yeah, never mind. This guy's by himself. Become a 3. There you go. Alright, I like it. I like it. So that's the basics of like terms. So it really makes me feel bad when I see a student do all this work. They have some gross, big, giant thing. They get all the way to here, and then they do this. Can you do 4x minus 1? No, of course. They're not like terms. So I still give points. But I have to take something away. Okay. One last thing about like terms. So are there any like terms up there? Yes, there are. So now we got the definition of a like term. It's got to be the same letters and the same amount of each letter. So what? I wrote these in reverse order. X times y, is that different than y times x? What's 2 times 7? And what's 7 times 2? Of course. Multiplication is commutative. You can commute them. You can turn them around. They mean the same thing. So somebody just wrote this out of alphabetical order. But I still have 4 xy's and 2 xy's, so I have 6 xy's. Now how about these guys? Hell no. They both have a's, but do they have the same amount of a's? No, this has 2 a's, and this has 1 a, right? So they're not like terms. You can't put them together. Cool. I like it. I like it. All right. So the next thing you need is distributive property. And I can't remember, I think maybe we talked about this. I can't remember now. We talked about this? Yes. So just to remind you guys, if I had -4 times 3a minus 2b, what would distributive property say?
-4, 5, 3a.
Yeah. So there you get. Good. So here you get.
-12a plus
Good. Plus
8b.
8b. All right. So is everybody cool with the distributive property? It's a wonderful name. Math people, we sometimes get a decent name for something. Distributive property because it distributes stuff. All right, good. I like it. Yes, ma'am.
If you have that, you're doing distributive property first and then like terms.
You have
If
to.
it's all
I love
one
it.
thing.
I love it. So here's the distributive property by itself. Now here's how it works with like terms. I really want this to make sense. So if I had 6m plus 3 times 5 minus... Sure, well, let's make it... Yeah, why not, Jeff? You can do it. I really want this to make sense. This is why you do distribution first. Because I want to put those m's together with the other m's that I see, but where are these m's? They're stuck inside here with the stupid... This is like the guard or whatever. Right? They're stuck in here. So distribution tears the walls down. Are these parentheses still here after I distribute? No, they're gone. They don't need to be there anymore. I've torn the walls down. Now stuff can move. I can't take this over here somehow. Another thing I see is people say plus 2m, plus 2m. Please tell me, well, there are two things. One, you can't break into this. Two, why does this make absolutely no sense? There's no equal sign. This is what you have to do if you have things on opposite sides of an equal sign. These are all together. So I see, real quick side note, I see this all the time. This, side note, if I had, help me out, you can do it, Jeff. What's 4x minus 2x? What's 4x minus 2x? 2x. Even if I throw something in between, it's not suddenly not 2x anymore, but I'll have people do this. Now they got 6x somehow. Wait. No. You're adding 4x to itself out of nowhere. That's not allowed. So why is equations allowed? Because you're doing the same thing to both sides. Maintains the equality. That's why it's legal. Here I got one side. It's like one scale, and I'm just putting more and more shit on it. Yeah, it's all. No. I don't have two sides to balance me out. I can't add anything to it, or else it's going to be out of whack. Okay, so please. So here, what would you do first?
Carry the 3.
Good.
$15.
15, thank you. Minus 6m, so what happens there? I like this.
15.
Yeah, what's 6m minus 6m? 0, good. I always get somebody who put an m here, they want the m to survive, but it don't matter how much you want the m to survive, it's dead. These 6 zombies killed these 6 people, and they all caught fire, they're all dead. I'm sorry. I need some Walking Dead to get that on operator. Alright, so let me give you this, and then those of you who know this really well, if you want to, you can look at the other side. But there's one side that says like terms, distributive property. Do those problems down there. There's like 6 problems, 3 in the middle, 3 at the bottom. Try those out real quick for me.
This is off topic, but wasn't there an ancient civilization that had at least 12 power stations sticking out of their shoulders?
base 12. Like the Babylonians had base 60. Base 12, off the top of my head, I don't remember base 12 civilization.
I remember someone saying they counted their shoulders.
Well, there's civilizations that didn't actually have a base.
Okay.
The words for their numbers correlated to toes. They kind of counted up one side of the body and then down the other.
Okay.
So the name for, 1, 2, 3, 4, 5, 6, 7, 8, 9, and maybe the name for 9 was the name for that finger. It's kind of neat. So I don't know if they had a base of 12, but 12 might have been an important number to them. Yeah. Everybody, you're doing the like terms, distributive property side, right? There's 3 in the middle and 3 in the bottom. There's also a solving equation side that I don't want you working on yet. There we go. Like terms, distributive property.